In this video we're going to complete example 2. Once again we've got quadratic equations that we're solving, and we know it's a quadratic because we have a pronumeral to the power of 2 here. And we're going to do it by factorising first. Now at the moment you can see only 2 of the questions that we're doing. We're actually going to be doing 6 questions. We're going to finish on question F. Now before we start these examples, I need to have a little discussion with you about multiplying by 0. I can remember when I was a kid, my dad would do this little activity with me where he would ask me to solve some really hard operation. So he might go 312 times 10 minus 6 divided by 3 plus 22. And then at the very end, he would take all of that and he would times it by 0 and ask me what the answer was. And my response was always 0. And I loved this because it sounded so challenging and difficult, and yet I knew the answer to the problem. Now this little activity here perfectly illustrates what we're doing when we solve quadratic equations by factorising. Let's say I had an equation that equaled 0. And let's say I have a set of brackets with quite a difficult expression in it. Let's have 2x over 3 minus 5. And then I'm going to have an x to the left of the set of brackets. And I'm asked, what does x equal? Remember the activity I did with my dad? It really didn't matter what was in the brackets, because once I multiplied this by 0, I got 0. So what I have here inside the brackets is actually irrelevant at the moment, because if I make x 0, then I'm multiplying this set of brackets by 0, and I'm going to get a solution of 0. So I can write down that x equals 0. Now there's actually going to be a second solution here, but it's comforting to know that one of the solutions is really easy to find. Now rather than finding the second solution, I'm just going to show you another example. Let's say we have something with 2 sets of brackets. Let's say we've got x minus 3 and x plus 2, and that's going to equal 0. Now remembering the activity that I used to do with my dad, let's focus on each set of brackets separately. Let's focus on the first set of brackets. How can I make this equal 0? Well, it's not too difficult. If x was to equal 3, then 3 minus 3 would be 0, right? Once I'm at that point where I get one set of brackets to 0, I don't really have to work out the second set of brackets, because 0 times anything equals 0, right? Yeah, there's actually a second solution here, and we find that by focusing on the second set of brackets as opposed to the first set. What could I do to make the second set of brackets equal 0? Well, if I had x equal to -2, -2 plus 2 is 0, and then 0 times whatever is in the other set of brackets will equal 0 as well. So these are our 2 solutions. Alright, let's get into our examples now, and the first thing we're going to do is we're going to factorise them. What do we get when we factorise b squared plus 7b? Well, we have a common factor of b here. So we'll take out our factor of b. B times b is b squared, and b times 7 will give us 7b. And this will equal 0. Now the first most obvious solution should be that b could equal 0. Because if we make b equal 0, 0 times whatever is in the brackets will equal 0. Let's focus on the set of brackets now. How can we make this set of brackets equal 0? Well, the second solution is that b could equal -7, because -7 plus 7 is 0, and 0 times whatever b is will equal 0. Let's now move on to question B. When you solve quadratic equations by factorising, you want an equation that equals 0. So at the moment, this equation's kind of in the wrong order. And what I'm going to do is I'm going to subtract 2a on both sides. That means on the left-hand side, I've got 5a squared minus 2a. what am I going to have on the right hand side after I've cancelled everything? Well, that basically means that this equation will equal 0. Now I'm at the point where I can factorize. What's my common factor here? Our common factor is a. Now a times 5a will give us 5a squared. And a times 2 will give us 2a, and this must equal 0. Now we're going to have two solutions here. The first most obvious solution is that a can equal 0, because if a is 0, what's in the brackets is quite irrelevant. Anything times 0 equals 0. So what's the second solution? Well, we need to make our set of brackets equal 0. And this is not as obvious as it was in question A. How can you make 5a minus 2 equal 0? Well, we're actually going to show some working here. What I'm trying to do is make 5a minus 2 equal 0, and I'm just going to use the normal rules I use to solve an equation. I'm going to add 2 on both sides in order to cancel the minus 2. Now we get 5a is equal to 2. I then divide both sides by 5, cancelling the 5's, which gives me a equal to 2 over 5. So if I plug a equals 2 over 5 into this set of brackets, I will get a solution that is 0. And as soon as you are timesing something by 0, it doesn't matter what the other thing is, we know it's going to equal 0. So we'll write down that a equals 0, or a equals 2 over 5. We'll now move on to question C. This is a monic quadratic, and when you factorize a monic quadratic, you want two numbers that add to make the 6 here in the middle, and you want two numbers that multiply to make the 5 at the end. So we'll write that down. They've got to add to make 6, and they've got to multiply to make 5. What are those two numbers? They would have to be 5 and 1, because 5 times 1 is 5, and 5 plus 1 is 6. We then write down two sets of brackets. Now this monic quadratic has the pronumeral x, so we're going to have x as the first term in each set of brackets, and we've got a positive 5 and a positive 1. So we're going to write plus 5 plus 1, and this will equal 0. Now we're going to have two solutions, and we just focus on each set of brackets separately, trying to make the brackets equal to 0. How would you make x plus 5 equal 0? Well, you just need x to be negative 5, because negative 5 plus 5 is 0. The other solution is that x could equal negative 1, because when we look at the second set of brackets, negative 1 plus 1 is 0, and that gives us our two solutions. Now moving on to question D. When you're trying to solve quadratic equations by factorizing, you need an equation that equals 0, and so far we don't have one. So we're just going to do some rearranging. I'm going to start by subtracting 10c on both sides. That's going to cancel the 10c on the right. The whole reason I'm doing this is I'm actually trying to cancel everything on the right, because when I cancel all of it, it's going to equal 0. On the left-hand side, we're left with c squared minus 10c, and that leaves you with negative 25 on the right. Now what we need to do is cancel out that negative 25. So we're going to add 25 to both sides of the equation. This will cancel the negative 25, which means that our equation is now equal to 0. And on the left-hand side, we have c squared minus 10c plus 25. I now have a monic quadratic, which means I need two numbers that add to make negative 10, and I'll write that down up here. They've got to add to make negative 10, and they need to multiply to make positive 25, or just 25. So what are the two numbers? Well, they're going to be negative 5 and negative 5, because negative 5 added to negative 5 makes negative 10, and negative 5 times negative 5 makes positive 25 because of the double negative. So I'm going to have two sets of brackets. They're going to equal 0. And because my monic quadratic has the pronumeral c, I'm going to write c at the beginning of each set of brackets. And now I just need my minus 5 written next to the c, like so. Now let's look at the first set of brackets. What value for c will make this set of brackets equal 0? Well, c will equal 5 because 5 minus 5 is 0. Now if I look at the second set of brackets, c will equal 5 again. Now there's no point writing down that c can equal 5 or c can equal 5, which is the same thing twice. So for question D, I actually have only one solution. And I spoke about this in a previous video that sometimes you get two solutions, like we had here for question C, and sometimes you get only one solution, like for question D, and there's even times where you get no solution. All right, let's now move on to question E. Here we have a non-monic quadratic. And it's non-monic because when you look at the y squared, it's got a number to the left that is not 1. It's a 2. So what do we do when we have a non-monic quadratic? Well, there are several steps that we need to follow. First of all, we need to take the 2 to the left of the y squared and multiply it by the negative 3. That's our first step. So 2 times negative 3 will give us negative 6. Let's now move on to step 2. So we're looking for two numbers that multiply to make negative 6. And I just took that negative 6 from step 1. And I'm also looking for two numbers that add to make negative 5. And I took that negative 5 from the middle term here. So what are the two numbers? The two numbers are negative 6 and positive 1. Negative 6, when added to positive 1, makes negative 5. And when you multiply these two numbers, you get negative 6 as well. So now we move on to step 3. So we look at our quadratic. The 2y squared and the minus 3 stay the same. So we have 2y squared, the minus 3, and it's going to equal 0. And we're going to split our middle term here in 2. And we're going to take the negative 6 and the positive 1. So I'm going to split it into negative 6y plus 1y. When you look at that, negative 6y plus 1y is the same as minus 5y. I've just split it according to the negative 6 and the positive 1. Now I need to factorize this expression, and I need to split it into two groups. I'm going to split it into 2y squared minus 6y and 1y minus 3. What do I get when I factorize the first group? Well, I've got a common factor of 2 and y. So 2y times y will give me 2y squared, and 2y times minus 3 will give me minus 6y. Let's close our brackets here. When I look at my second group here, there are no common factors. So the only thing I can really factor out is 1. And 1 times y gives me 1y. And 1 times minus 3 will give me minus 3. Now this will all equal 0. And you might remember, when both sets of brackets are the same, we write them as one set of brackets. We're going to write the y minus 3 in one set of brackets. And then the other two terms, the 2y and the plus 1, will go in their own set of brackets, like so. This will equal 0. So we've done all the hard work now. We've factorized our expression. All we need to do is make each set of brackets equal to 0. Now the second set of brackets is really simple. If we make y equal 3, 3 minus 3 will equal 0. So that's going to be our first solution, y equals 3. Our second set of brackets present more of a challenge. We need to make 2y plus 1 equals 0. So we'll write that down. 2y plus 1 equals 0, and we're just going to solve it for y. We'll subtract 1 on both sides of the equal sign, leaving us with 2y equals negative 1. We now divide both terms by 2. This will cancel out the 2 next to the y, leaving us with y equals negative 1 over 2, or negative 1/2. So we now have our two solutions, y equals 3 and y equals negative 1/2. So we'll write that down at the end, that y can equal 3, or y could equal negative 1/2. We now need to move on to question F, and I'm noticing that I'm running out of room, so I'll start with the blank slate. When you first look at question F, it looks like it's not a quadratic. You'll also notice that we've got a fraction and the denominator is d, and I always say that if you've got a fraction, focus on getting rid of that fraction first. So we'll see what happens when we do that. We're going to times every term by d so that we can get rid of the fraction, so we can cancel that denominator. 3d times d is 3d squared. And 11 times d is 11d. And then because we've cancelled the d's, we're left with minus 6. Now that we've done that, it's starting to look more like a quadratic, except we want to make it equal to 0. So we'll subtract both sides by 11d. The reason we're doing this is we're trying to cancel everything on the right hand side, which will make it equal 0. 3d squared minus 11d equals negative 6. And now we add 6 to both sides of the equal sign, like so, giving us 3d squared minus 11d plus 6 equals 0. Now we've got a non-monic quadratic. So the first step to factorising this is multiplying our 3 by 6. So step 1, 3 times 6 is 18. Now moving on to step 2, we're looking for two numbers. They need to multiply to make 18, or positive 18. And they need to add to make the number in the middle term. They need to add to make negative 11. Now, I always like to focus on my multiplication first. What kind of numbers multiply to make 18? 6 times 3 makes 18, but I don't think I can make 11 from 6 and 3. 9 times 2 makes 18, and I reckon I could make 11 from 9 and 2. I'm going to say it's negative 9 and negative 2, because negative 9 added to negative 2 makes negative 11. And when we multiply them, we also get positive 18 because of the double negative. So now I take this expression, I leave the 3d squared and the plus 6 the same. So I'll write that over here, 3d squared and the plus 6 the same, as well as the equals 0. I'm going to split the minus 11d in two parts, and I'm going to split it according to the negative 9 and the negative 2. So I'm going to have negative 9d minus 2d. The quadratic I have here is exactly the same as the quadratic I have over here. I've just split the minus 11d into two parts. I'm now going to split this into two groups, and I'm going to factorize each group. We'll start with the first group over here. What's the common factor for 3d squared and minus 9d? Well, I have a common factor of 3 as well as d. So I'll factor out the 3 and the d. 3d times d will give me 3d squared, and 3d times minus 3 will give me minus 9d. What's the common factor I have for the second group? I can see a common factor of 2, and I'm also going to factor out minus 2. Minus 2 times d will give me minus 2d, and minus 2 times minus 3, because of the double negative, will give me plus 6. This will all equal 0. Now I've got two brackets exactly the same, which is what I wanted, and I'm going to take these two brackets and put them in one set of brackets as d minus 3. I then take the other two terms, the 3d and the minus 2, and I'm going to put them in the other set of brackets. This will now equal 0. I've done all the hard work. I've factorized my expression. Now I just need to make each set of brackets equal to 0. How would I make the second set of brackets equal 0? Well, that's quite simple. I would just make d equal 3, because 3 minus 3 is 0. That's one of my solutions. To get the second solution, I need to make 3d minus 2 equal to 0. If I have 3d minus 2 equal to 0, I simply add 2 on both sides, like so, giving me 3d equals 2. I then divide both sides by 3 in order to cancel the 3, and I get that d equals 2 over 3. So I get my two solutions. D could equal 3, or D could equal 2 over 3. Now I'm going to make the marker's life a little easier. I'm going to put rectangles around my two solutions so that the marker can find them easily. And I'll just write or here. I'm just stating that D could equal 3 or D could equal 2 over 3. Anyway, that concludes our video on example 2. Remember to read the description below for links to workbooklets that relate to this video.